Welcome back to the discussion class of improper integrals. As I've said, in this part, we will be having integrals with infinite discontinuity. I hope you're ready again. Let us begin. We will start with this example. We want the integral from 6 to 8 of 4 over x minus 6 raised to 3 dx. Okay, so ganun pa rin ang ating step. Ang unang step, it's to check the continuity of our function on the given interval. We note that our function, this is actually continuous everywhere except when x is 6. And in particular, this is continuous on the interval 6 to 8. We include 8 and we exclude 6. And we may also note this has an infinite essential discontinuity at x equals 6. Okay, so if those hold, what do we have? We have 6, the integral from 6 to 8 of 4 over x minus 6 cubed dx. This is given by, this time we replace the limit of integration kung saan mayroong discontinuity with the variable, say t, and then we take the limit of the integral as t goes to 6 mula sa kanan. So as t goes to 6 from the right. Okay, so again, the question is, what is the antiderivative of our function? We again look at this as 4 times x plus x minus 6 raised to negative 3. So that the antiderivative is easy. It's 4 times x minus 6 raised to negative 3 plus 1, or negative 2. And then we evaluate from x equals t to 8. And then we take the limit as t goes to 6 from the right. Okay, let us substitute. What do we have? When x is 8, we have 4 over negative 2. That is just negative 2. So we have negative 2. 8 minus 6. That's 2 raised to negative 2. Minus negative 2. So plus 2. T minus 6 raised to negative 2. Then ibababa ko na yon. So I get t minus 6 squared. 1 over t minus 6 squared. And then again, scratch tayo sa gilid. We have negative 2 over 4, or that's negative 1 half, plus 2 over t minus 6. When t is 6, this goes to 0 from the right, and then square mo pa. So what do you have? You have negative 1 half plus this one goes to positive infinity. So the final answer actually is, this is positive infinity, which means that your function, that your integral diverges. Okay, that's for number 1. I hope that's clear. Again, kung may question, pwedeng i-pause anytime video, rewind, or sulat muna ang tanong and then itanong sa teacher later on. Okay, let's move on and have this next item. We want the integral from 0 to 1 of the 1 over e raised to negative x minus e raised to x dx. Okay, again, first step is to always investigate the continuity of our function. Where is this continuous? Or siguro mas magandang itanong saan ito hindi continuous. Ito ay hindi continuous kapag yung denominator mo ay equal to 0. That is, if e raised to negative x ay equal to e raised to x, take the natural logarithm of both sides, you get negative x equals x. And when is that true? Precisely when x is 0. So this is actually continuous everywhere except when x is 0. In particular, this is continuous on the interval 0 to 1. We include 1 and we exclude 0. You may also note that at x equals 0, your function has an infinite essential discontinuity. So if that holds, you want the integral from 0 to 1, dx e raised to negative x minus e raised to x. Paano natin ito gagawin? We again replace yung limit of integration kung saan may discontinuity, so 0, palitan ng t, and then copy everything else, and then you take the limit as t goes to 0 from the right. Okay, now, we want to get the antiderivative of our function. As you can see, hindi yan masyadong trivial. So, kapag hindi ganun kadali makuha ang antiderivative, pwede natin kunin separately. So, meanwhile, let's take the general muna, the general antiderivative of e raised to negative 1 over e raised to negative x minus e raised to x. How do we do this? There are actually two ways. I'll show you this one. And then yung isa pang way, sabihin ko na lang later. So you have 1 over e raised to negative x minus e raised to x. What I'll do is I'll multiply e raised to x to both the numerator and denominator. So we'll have e raised to x over e raised to negative x times e raised to x. That is just e raised to 0 or 1 minus e raised to 2x dx. And then, here, we use u substitution. You let u be e raised to x. You have du equals e raised to x dx. So, you have du over 1 minus u squared. And then from here, recall, we can use partial fractions. So, 1 minus u squared, ano ang kanyang factors? You have 1 plus u and 1 minus u. And I leave it to you to verify that you'll have here 1/2 and 1/2 here as well. And then this one is easier now to integrate. You have 1/2 ln absolute value 1 plus u plus 1/2 ln absolute value 1 minus u plus c. Balik lang natin si x. We have 1/2 1 plus e raised to x plus 1/2 ln 1 minus e raised to x plus c. So that's the general antiderivative of our function. Let's go back to what we want. We want the integral from 0 to 1 of dx e raised to negative x minus e raised to x. Sabi natin, this is just the limit as t goes to 0 from the right of t to 1 dx over e raised to negative x minus e raised to x. Now, we know the antiderivative of our function. It's 1/2 ln absolute value 1 plus e raised to x plus 1/2 ln absolute value of 1 minus e raised to x. And then we evaluate from x equals t to x equals 1. Now, let us try to substitute. When x is 1, we have 1/2 ln 1 plus e plus 1/2 ln absolute value 1 minus e. When x is t, what do we have? We have 1/2 ln 1 plus e raised to t plus 1/2 ln 1 minus e raised to t. Okay. Now, mag-scratch tayo. Etong mga to, no problem, they are real numbers. So, let's say that's a real number k. Minus, as t goes to 0 from the right, ito magiging 0 lang, ano? So e raised to 0, so that's just 1. So you have 1/2 ln of 2 plus 1/2 ln 1 minus e raised to 0 is again 1. So ln of 0 actually, ln absolute value of 0. At alam natin ng ln, the graph of ln is something like this. So as x goes to 0 from the right, papunta siya kay negative infinity. So dahil may absolute value, this goes to 0 from the right. So this one goes to negative infinity. So that we have a real number here plus negative infinity. Of course, that will be dominated by negative infinity. So your final answer is negative infinity, which means that your integral diverges. Okay, that's the second example. I said earlier na may second solution. Actually, yung second solution ay dito lang, no, sa pagkuha lang ng antiderivative. What you can do kasi is, you can recognize that this is also equal to 2, negative 2 over, negative 1/2 over e raised to x minus e raised to negative x over 2 dx. Bakit ko to ginawa? Kasi, if you recall, this one is a special function. This is the hyperbolic sine function. At dahil nasa baba siya, it's also equal to the, kapag tinaas mo na sa hyperbolic cosecant. And then, if you take the integral of this one, you'll have ln of cosec x minus the hyperbolic cotangent x plus c. So, you may also use this antiderivative, pero mas mahirap ito kasi you'll also use L'Hopital's rule in evaluating the limit. But that's another way. Alright, so that concludes the second part of our discussion. Tutuloy natin to sa third and final part. So again, you may take a quick break before proceeding to the next video. See you!